here, and please interrupt me. So we meant this to be some kind of conversation. And so we're going to talk about nitrogen management in organic crops. How many organic avocado growers I have in the room today? Okay, at least 4. How about citrus, organic citrus? At least 1. How many organic grapes? 1. How many organic vegetables? Oh. How many organic something else that I don't know? Good. How many non-organic that are just here because they need the hours? Okay, that's refreshing. That's refreshing. So again, if you need hours, talk to me. If you need hours, talk to me. And we also have office hours on the first Thursday of the month at 1 p.m. in that room next to this. And you just sit with me for 1 hour and I bore you to death. And then I take you upstairs and we tell Tasha that you got 1 hour of education. And that way I can make it a little bit more relatable to each of you. So I've got cards there. Grab one on your way out and talk to me or talk to Tasha and let us know when you would like to sit with me with education. So the other thing is that I've got a email. I got emails when we organize these trainings and with these seminars. I send emails. So if you scan that code with your phone, you can put your email there and you will get the email updates. And also on the website that I put there, I cannot say because I'm not a member of the Irrigating Lands group, but I know that you can access and you get to a dashboard. And I know more or less, we'll talk to Tasha. I know that Tasha manages that dashboard, and through the dashboard, there is a lot of these very seminars that are recorded. So you can, if there is a topic that you missed and is relevant to you, you can go on YouTube through the dashboard and see that topic and bring a lot of coffee so you don't fall asleep while watching, and you get an hour of education that way. So the dashboard is where you go to find those. So we're going to talk about concentration of nitrogen in leaf tissue. Why is that interesting? Why is that important? How much should it be? How much should it be, first of all? Who has a tissue sample result right there? Who wants to tell me?
Well, optimal range is 3.5 to 4.5.
3.5 to 4.5. Is that on dry weight or on wet weight?
So my results.
Yeah, sorry about that. If I take a leaf of that Dracaena, is that the Dracaena? I cut it. Is that the Dracaena? Okay. I send it to the lab. How much? What do they do in the lab? They put it in an oven. They dry it. Say what? Say what?
Squeeze test.
They dry. They put it in the oven. They dry it, and then they put it in machine that is called the elemental analyzer or a Lachat or whatever that is, which tells you the concentration of nitrogen. That concentration of nitrogen will be around 3-4%, 5%, 6% sometimes. So the concentration of nutrients in a leaf of the plant are relatively constant, independent of what that plant is. And so we're going to use that concept that if you know the concentration, you can multiply by your yield and you get the mass of nitrogen that you have removed with your yield. And so you can say, well, I grew all these lettuce. I grew all these organic lettuce. I know that my lettuce removes 100 pounds of nitrogen. And that's why the water quality regulators now want to do the removal coefficient to tell them how much nitrogen you have applied and how much nitrogen you've removed. Hey guys, welcome. There's breakfast there.
Thank you.
Then we are going to talk about mineralization. Why are we interested in mineralization in organic systems? Why do they call it a front load system? I don't know if you're shy or yes, speak up, no hands.
Yeah, but because you put it on and then it breaks down over time and.
It breaks down over time. breaks down over time. Plants cannot absorb it as it is. I brought there some fertilizer, pass them around. Some are stinky because they come from fish or from soy. Pass them around. So this is an opportunity for you to look at these things that maybe you wouldn't get otherwise. But the idea is that it needs to break down. Microbes needs to break it down before plants can pick it up. Then we're gonna go through some math. I apologize. And many of you probably know already how to do this, but the idea is how do you calculate how many pounds of fertilizer you need to apply 100 pounds of nitrogen. So some of you will know already, and I apologize, and some others won't, and hopefully we'll learn something. And then we're gonna talk about how to calculate how much you pay for a pound of nitrogen. When you compare these fertilizers, you want to compare them on the basis of nitrogen. Maybe this stuff has, I don't know, 2% nitrogen in it. Put it around, smell it, look at it. These other stuff has 3% of nitrogen in it. Smell it, I don't know if you want to smell it. If you're brave enough, smell it. And this some soy stuff that's got 15% nitrogen in it. So 15 against 3, right? So this is way more concentrated. So when you buy these, you buy a lot more nitrogen than if you buy that, right? So when you look at your numbers, when you look at what you want to buy, you need to calculate the cost of 1 pound of nitrogen. How many dollars you pay for 1 pound of nitrogen, not for 1 pound of fertilizer. Who's with me? Who's bored? Everybody? Okay, so then at the end, we're gonna talk about injecting liquid fertilizer. You get a lot of plugging if you don't do it right. And sometimes you get plugging even if you do it right, but you need to do everything you can to avoid the plugging. And then we're gonna talk about phosphorus only for 1 minute, because this is a nitrogen talk, not a phosphorus talk. So these are some papers that are out there. I thought I was gonna get a ton of organic vegetable growers. So I got a shoot somewhere in the middle. But this is an article about all organic crops, fertility management for all organic crops, and it's not too long, and it reads well. So you can take a picture if you're particularly interested and look it up, and you cannot find it, talk to me. And if you're a vegetable grower, which I'm guessing you're not, that's a book from Tim Hart that talk about everything you always wanted to know about managing nitrogen in vegetables. And there's a chapter that talks about organic. So now I'm gonna do this. No, I'm not gonna do it. So from home, if you have any questions or comments, please unmute yourself and ask the question. I hope you can hear me well and see me well. And so who wants to tell me what's wrong with this scale? Even if you're not a vegetable grower, you may guess. Why? So somebody says low in nitrogen. So the question is, why is it low in nitrogen? I cut the faces in that picture because I don't want to show who it is. I don't want to comment negatively on their nitrogen management. But that's a typical telltale symptoms. Who wants to tell me what it is?
They're stunted.
Maybe. Yes, sir. Yes, sir.
The lower leaves are missing.
Look.
Very small, very yellow.
Thank you. Older leaves are yellow. Why is that happening?
They're dying.
It's taking the nitrogen to the young growth.
It's taking the nitrogen to the young growth, some gentleman in the audience says. So it turns out that nitrogen is a very mobile element. And so the plant, when it runs out of nitrogen, says, well, I've got these old leaves, but I need to grow. Let me get the nitrogen out of these old leaves because I can move it around, and that helps me grow from where I want to grow. So a typical telltale symptoms in any plant, in ornamentals and in vegetables and in everything, is that the old leaves are yellowing. And this is common, you see it all the time in organic production of vegetables. And that's due to the fact that the mineralization of organic matter that we're going to talk about in a minute, that happens naturally, provides some nitrogen, and that's why you see plants growing even if they're not fertilized in natural environment. But then nitrogen is really, it's small. It's small and it's not enough. That quantity is not enough for a plant like kale to grow to its full potential. And it turns out that also kale likes a lot of nitrogen, and all the cabbages and all the brassicas are hungry of nitrogen. And the other thing that maybe is a little bit more subtle, but if you grow this way, you are not reaching the full crop potential. Somehow you're making all the other resources that you had invested in that crop inefficient, because you still have applied water, you still will have put labor in it, it still takes the land that it took, right? So it produces 50% less yield. Everything else is inefficient in a way. So
Sunglasses.
not having applied those 50 pounds of additional nitrogen makes you inefficient in your water. And in San Diego, the last thing we want to do is be inefficient with our water. Who wants to tell me about forms of nitrogen? What kind of form of nitrogens are out there? Who wants to speak up? No hands, just open your mouth.
What about meal?
Yes, from home.
What about feather meal?
Feather meal is
Okay.
one organic form, and it's an organic fertilizer. And but more in general, when I go to the gym and I want to make my muscles really big, right?
Yeah.
And I come out of the gym and I drink this shake. What does the shake say? Protein. So in the organic world, protein is what contains nitrogen. And it turns out that proteins are chains of amino acids. So you and I, when you eat something, and I hope I don't say something too wrong from a medical point of view, when I eat a steak, my stomach or my guts break up these proteins into amino acids. Guanine, thymine, all those things. And then my bloodstream picks up those amino acids, and that's what we absorb as humans, as animals. We absorb amino acids. Am I right? We can't. Yeah. If I drink that glass of fertilizer, if I drink a glass of nitrate, my muscles stay the same. Maybe it hurts me too. I don't know. I cannot absorb it. While a plant instead absorbs nitrate or ammonium, because plants can absorb inorganic or mineral forms of nitrogen. So they absorb nitrate, they absorb nitrites, and they absorb ammonium. They absorb a little bit of amino acids too, but for all intent and purposes, 90% of plant nutrition comes from inorganic forms. And then finally, there is molecular nitrogen, which is 80% of what you and I are breathing in and out right now, and it's completely inert, and you cannot use it. It's a gas, right? Unless you're a veg, that then you can take nitrogen from the air. So legumes can take nitrogen from the air, but only legumes. Any questions? So which one are these of using fertilizers? Somebody from home said feather meals. That's a source of nitrogen that is organic. So it's mostly proteins and amino acids in there. And instead, all the synthetic fertilizers are either urea, which is an organic compound, or nitrate or ammonium. So you have seen this a million times, and I don't want to bore you with this too much, but I wanna point out this passage here that they call ammonification, but I call mineralization. Here in the middle, from those at home where you see the cow and there is an arrow that goes down. So in organic production, when we apply fertilizer, either is a part of an animal, or maybe it's a waste that comes from an animal, like manure.
Ooh, getting ready to pour concrete.
And it's got some organic form of nitrogen in it that needs to be mineralized. So again, your plants cannot absorb proteins as they are. You need to have this mineralization, process that happens in the soil.
I saw her when I went to town and when I came back, I don't know if she was out there. I'm like,
I apologize. So please, if you're home, mute yourself, because otherwise we can hear you here in the room.
Concrete.
But unmute yourself if you want to ask a question. And so then we got mineralization. So this is what you need, mineralization, which becomes ammonium.
Lecture about fertilizer.
Here we have another arrow here, and it's due to the bacteria that are in the soil. There is a group of bacteria called Nitrosomonas that like to turn ammonium into nitrite, and then there's another group called Nitrobacter that like to turn nitrite into nitrate. And this happens really fast. And it's mostly modulated by temperature and soil moisture availability. But we're in San Diego, so temperature typically high, soil temperature typically high, and if you're growing something, typically you irrigate. And so this process is not limited. And it's
Clear
not
on this side. Clear.
When you say fast, hours, days, how fast?
maximum weeks, days or weeks. Yeah, and you see, I'll show you some data in a minute, where they put in a chamber, they put this stuff in a chamber, feather meal or guano in a chamber, and they measure how fast it becomes ammonium, and then there is that, and you see weeks, and then this passage happens really fast. But you can see it in the field. I'll show you in a minute the nitrate quick test. It also measures nitrites, and you can try to apply ammonium, and a week later you can take a sample and you can see how much nitrate and how much nitrite is there. You'll see there is very little nitrite, right? Because it's intermediate passage and it goes real fast.
Mhm.
And a lot of it already became nitrate. Why is nitrate the problem? Why we don't like, so to speak, to have nitrate in our soil?
It leaches.
It leaches. Where does it leach to? To the groundwater. Do water quality regulator have a sense of humor about that? Not really, right? Do we get in trouble with them if we do a lot of leaching? We do. So that's the problem with nitrate. It's very leachable, and the reason is that it's negatively charged, and the soil also has negative charges. And so it doesn't stick to the soil. Electronically, it doesn't stick to the soil like ammonium does. And so it leaches. What else does nitrate do?
Evaporates.
This arrow here.
Evaporates.
I guess you can say it evaporates. The process is called denitrification. There is some bacteria that eat it, use it for their metabolism, and they turn it into the N2 in the atmosphere that is not a fertilizer anymore. When does that happen? Who knows? What are the conditions that favor denitrification?
As in the same conditions that bacteria grow in.
Drought,
Heat and moisture.
Good guess, but it's actually the opposite. It happens when you are in anaerobic condition, when it's too wet. When your soil is too wet, when you over-irrigate, you get denitrification. So check this out. If you have a very sandy soil, and you over-irrigate, you get a lot of leaching. If you have a clay soil, which doesn't drain, you over-irrigate, you get a lot of denitrification. So whatever you do, whichever soil you have, your nitrate somehow disappears. So it's a leaky system. It's a leaky system. So that's why you need to be careful with your irrigation management. Questions? Comments? And then there's synthetic fertilizers that produce nitrate, ammonium, and sometimes urea that non-organic folks use. So this is a super busy slide, and you don't have to understand everything, but I try to pack as many possible examples of the sentence that I put at the top. So if there's only one number that you remember from this talk, is this 5% of dry weight, more or less. Like I said, for the Dracaena, and ornamental growers that I have in the room know very well that when they send the sample to the lab, they get more or less this number across very different species, very different plants. But this is an example with lettuce from this article that you can look up, and they have all these samples, and they are around 6%, 5%, 4% of nitrogen on dry weight. That's for lettuce. I was at Cultivate 2 weeks ago, and there was a talk on pentas, and they showed this table, and so I took a picture. Check this out: pentas sufficient 4% nitrogen, 5% nitrogen. So it's similar, right? It's around here for pentas, just like for lettuce. And this is an article on avocado for my avocado friends. And the usual suspects are the authors of this article, so we trust them. We have good reason to trust them. And there we get 3% nitrogen, and there we get about 0.5% phosphorus. And in the pentas, we go about between 0.5 to 1% phosphorus. So I'm trying to bore you to death with all this data just to make these 2 points that you cannot see, because something is bothering us. Okay, so 5% of nitrogen and 1% of phosphorus. Just remember this. The plants in their tissue need way more nitrogen than they need phosphorus. Way more nitrogen than they need phosphorus. And that's why Fred, when we talk, he says, well, you don't really need 20-20-20. You don't really need 20-20-20. Maybe you need 17-5-17, right? So you need a lot of nitrogen, you need little phosphorus, and you need a lot of potassium. Is that right, Fred? Sure. Okay, good. I got the big shooters in the room, so I don't wanna, I'm scared. I don't wanna say things that are not true. So now we know how much concentration is in that plant. But then you can say, well, I know the yield that I will get out, so I can multiply the 2, and I know how much nitrogen was in that yield. And so up here, I've got vegetables between 120, 150 to 100 pounds of N per acre. The unit is pounds of N per acre, pounds of nitrogen per acre. That's the reference point. And you see that across vegetables, you get anywhere between 100 to 200. And earlier I said that the brassicas are nitrogen hungry, and that's what I meant here. For avocados, here I have a study from Gary Bender, which we trust, on organic avocado. He says that by the seventh year, you need 150 pounds of nitrogen per acre, and probably by the 4th, 5th year, you're already at 100. So you see the similarity, right? You were at 120, 200, you're 100, 150, right? I mean, I cannot think of more different crops than avocados and onions or melons, right? But there is commonalities that come from the fact that the plants have a metabolism just like you and me, and the concentration of those elements in their tissue is more or less constant. For strawberries, I get 90 pounds per acre. Do I have any organic strawberry growers? Where's Neil? And oranges, I couldn't find some organic, but this is for conventional, and again, the same number shows up, at 6 years, 66 pounds of N per acre, 7th year, 110 pounds of N per acre. So if you want to remember only one number from this talk, just remember that more or less, across different crops, the reference point, the rule of thumb is 100 pounds of nitrogen per acre. Are there questions? Questions from home? Okay, so we said earlier that we get some nitrogen from the soil. The soil naturally mineralizes some organic matter, and that's why you see weeds. Where does those weeds on the side of the sidewalk, where did they get the nitrogen from? Some guy didn't go there and fertilize them, they grow by themselves, right? So they get the nitrogen from some mineralization of organic matter, and that helps you. That helps you because you get, it's a godsend, you get some for free. How much is that some for free that we get? Who wants to guess?
Does it depend how much organic matter you have in the soil?
Very good, it does. How much organic matter you get in agricultural soils in California, more or less?
2%?
2% is a good number. So how much, and if you work them a lot, if you till them a lot, and if they're very sandy, then you get less, right? If they're very clay and you get less tillage, then the organic matter goes up. But 2%, 2% is a good number. So this is some data from a soil that has 1.35% of organic matter. 1 foot of that foot mineralized about 70 pounds per acre, and it didn't get to 100. So it is around 90 or 85. And you can say that, you can see that we're talking about 8 weeks, so 2 months. And you can see that the temperature, each of these lines is a different temperature. So we would probably look at these 2 ones because it's at 20 and 25 degrees. So what I'm trying to say here is that maybe in the best conditions, if you have a relatively high soil organic matter, maybe you can get 80 or 90 pounds out of that soil for free.
Nope.
Any questions from home? And this is another.
So if you're talking about putting on orchard mulch or you let avocado leaves naturally compost, is that what you're talking about here? That they will decompose into soil nitrogen mineralization? Is that fair to say?
Somewhat, not that directly. I was talking about the organic matter that is already in the soil. Now, if you let those leaves fall on the ground and naturally compost, certainly they will provide some nitrogen.
As you get to the stoplight.
I don't know how much exactly of it, but I'm sure we can find data for dead dry avocado leaves falling on the soil. But that's certainly another input. That's in the category of what we call crop residues. And I'm going to talk about those in a minute.
Okay.
But those will directly provide nitrogen to the soil, but they will also increase the organic matter in the soil that then next year will do exactly what I'm showing in this slide. So everything you can do to increase the organic matter content in your soil is a good thing for soil health and for water retention and for a lot of things that I'm not going to talk about today. But also it increases your nitrogen mineralization.
Okay.
Yes. Question.
I mulch with wood chips around avocado trees, and I noticed that it's a real good, traps moisture well. Yet I've heard that decaying wood chips will rob your soil of nitrogen.
That's very true. So it's not unusual. It's not unusual for conventional system when you apply wood chips also to apply urea or to apply some nitrogen fertilizer to counterbalance the effect.
It takes a while for the wood chips to start breaking down. Isn't that when it happens?
Yes, yes. So luckily it will be slow. Luckily it will be slow. And substrate guys here, they know very well that if you add hardwood sawdust in your substrate together with your in your potting mix of ornamentals, it'll do what we call nitrogen draft, right? You don't want to put some high carbon to nitrogen ratio material, and wood chips are high. They have a lot of carbon compared to the nitrogen that they have, and so the microorganisms will eat it up because they have a lot of carbon. But this process will be limited by nitrogen, and so they will fix the nitrogen that is in the soil. So you need to be careful. And again, you may, if the fear is that your crop will not have enough nitrogen, then you can apply some nitrogen source together with those wood chips. But that's a well-known problem, that you're trying to increase your water efficiency and your worst enemy from the nitrogen point of view.
Can I ask
Yeah.
a question about that? So if you apply avocado wood, for example, that's gone through the chipper and has been left to compost or ferment really for say 6 months, and then apply to the soil, does that leach out the nitrogen as if it was a wood chip?
So the wood chip does not leach out the nitrogen. What it does, it fixes the nitrogen into microbial biomass. So it's not that you lose it forever like you would if it leaches. And it's not like you hurt the environment and get in trouble with water quality regulations as you would if it leaches. It doesn't leaches, it fixes. It gets fixed in that soil. So it's still there. The good news is that it's still there, but it's not immediately available to your crop.
So it's not really a very good thing to do then, really.
So there is another twist to the plot. If you use wood chips, yes, they fix a lot of nitrogen. But if you use something that is composted, then the most liable fraction of that organic matter has been already used, and so then you will have still organic matter, but it's in the fraction that is lower to be broken down, and so it will also fix nitrogen way slower. And then at the same time, you also have mineralization, so it's not as bad. It's not. I guess what I'm trying to say is that applying composted materials is not as bad as applying fresh wood chips. But again, as I was saying earlier, the king, and I'll show you some data, the king indicator there is the carbon to nitrogen ratio. You want to know the carbon to nitrogen ratio of the material that you're applying, and that tells you if there will be nitrogen fixation or nitrogen mineralization. Did I answer?
Okay, thank you. Yeah,
You're
thank you very much.
There was another question
one
here that I have to keep going.
A quick one. A lot of times wood chips are used for weed control. Is that drawing, locking up of the nitrogen part of what keeps the weeds from growing, or is it more just the physical barrier that's put between the soil?
That's an interesting question. You know, the common knowledge is a physical barrier, right? Is the shade, but you know, the nitrogen may play a role too. Yeah. Yes.
I was wondering, what kind of time period are we talking about for the microbial that's fixed the nitrogen till it's released to being usable nitrogen product for your crops?
So I'll show you some data on mineralization, but you know, on the x-axis, typically you have weeks, and typically we're talking about 2, 4, 8 weeks.
That's for the microbial use of the wood chips in this case, fixing the nitrogen and then releasing it in 8 weeks?
No, not releasing it.
That's the time period I was wondering about.
So fixing it is very fast, depending on how fresh that material is. Releasing it, again, it happens over time, and this is what we're
Next slide.
Here's what you're showing here.
No, next slide.
In the soil, this soil has 1.35% of organic matter. Maybe somebody put some wood chips there, maybe it comes from crop residues. For
Your
some
phone's
reason,
on my ear.
organic matter
Right
there.
turn here.
And the mineralization, this is the mineralization rate, right? But again, if there is a lot of carbon, it will fix instead. I guess this curve will be flipped over. Instead of releasing oxygen,
In the
it
big 5-story building.
I was wondering, when is it unfixed? Are we talking about years or?
both. There is a fraction, and I'm gonna show some data. There is a fraction that will be released within maybe next year. And then there is a fraction that stays there longer. But you're asking some $1 million questions there.
But you answered your question. So years, but it's
Yeah.
still there. It hasn't gone.
It's still there, and some will come out, but slowly.
Parking garage.
So
Jerry, is it fair to say, going back to sort of this original wood question
Yeah.
that everybody's brought up, is it because trees, the wood is mainly made of cellulose and there's not a lot of
Yes.
nitrogen there?
yes,
So cellulose is not a protein which doesn't contain nitrogen. So that's what we have to be thinking about when we put wood limbs and we prune trees and we arrange them. We maybe want to keep them away from the root zone of the tree, but put them out in the spaces between trees or something.
Yes, you said it right. There's a lot of cellulose. There's a lot of all sorts of stuff, lignin. There's a lot of, but the point is that in wood, the carbon to nitrogen ratio is
the
high.
level you want.
Yeah, but we're gonna go back to the.
Yeah, I understand that.
If you take leaves, that ratio will be
The
lower.
other end of the building.
Be more nitrogen in it. So yeah, you said it right. Now I'm gonna.
Okay, thank you.
You're very
I have
welcome.
one last question.
The tree.
I have one
Yes.
last question, Jerry.
Over this way.
Are you
Yeah, where those
talking
steps
about
are.
cover crops?
I'm gonna mention cover crops a little bit later. Hey, Mary.
Okay.
But if I don't address it, talk to me later and I'll address it for you. But now I want to keep moving, otherwise I'll be late for my 8:30. You will be late for your 8:30 meeting with your lives. The problem with nitrogen is that we need to match, we need to synchronize. We want to synchronize our application with uptake curve. This is an uptake.
This entrance on this side is as flatted as it is on the other side.
And this is another one, and it looks like that all the time. And the shape of this curve is something that very well describes a lot of
Walker here and Kate.
biology processes, including humans.
Will be fine.
There is a latency period, then there's an exponential period, and then it levels off. This is the shape of how much fast your
It's in my pocket at the moment.
your plants
Around and get
pick
mine.
up.
Can those people at home mute themselves? Because I
Yeah.
can barely hear Jerry.
Yeah. Please mute yourself if you're at home. I'm gonna do that too. So I apologize if I arbitrarily mute you, even if you weren't talking. Yeah, so plants uptake nitrogen, and you need to apply it earlier, but how much earlier? What if you apply it too early and it sits there for 2 months, before the plant uptakes it? What's the risk? Leaching. All those things we talked about. It can leach, it can demineralize, it can run off with some storm, it ends up in the river and all that stuff, right? Denitrification. That's right, it can denitrify if you get anaerobic condition, etc. So the trick is I want to apply right before. But So this would be a common, conventional fertilizer nitrogen management, but with organic, you wanna apply it earlier. Because you need to give time for that mineralization to happen. And so that's why organic system, they call them front load systems. Front load system, because you front load a lot of your carbon, you would apply everything at the beginning. Or maybe you're applying half at the beginning and you will do a side dress of another half, right? Because you gotta make sure that it's mineralized by the time that the plant uptakes it. Now, how long does it get to mineralize? How long does it get to mineralize? This is a study on high nitrogen fertilizers. Blood meal, cider meal, guano, fish powder. The percentages are really high for organic fertilizer, 13, 15. This stuff, where's that stinky stuff? Well, that's one of the stinky things, but I've got another stinky thing somewhere. This one has 16%. This one is, they call it grower secret. You can see the label here. It's got 16% nitrogen in it, and it comes from soy. So it's got a lot of nitrogen in it, and you can pass it around and smell it if you dare. And so they studied, so this is 16%. So these are comparable to that. And check this table, they say 1 week, 2 weeks, 4 weeks, 8 weeks. And these are different temperatures. So we wanna look at these two columns that are the warm temperatures. And in 1 week, we got 50% of that nitrogen out of it.
Also
Already.
depend on your irrigation cycle, wouldn't it? Because the water is leaching that, you're top dressing it. So the water is leaching it into the soil. So the amount of absorption would depend on irrigation timing also.
I'm gonna talk about that a little bit also. It depends also on placement, you're saying. If I drop it on the top of the soil and I have the water make it infiltrate, compared to if I incorporate it into the soil, then the mineralization will be different. I'll show you that in another slide. But this is assuming that you mix it in. This is assuming that you mix it in, you work it into the soil. In 1 week, you get half of that nitrogen out of it already. And this is because this material, it has a higher or low carbon to nitrogen ratio. Low, very good, low, because it's got a ton of nitrogen in it and very little carbon, right? So if I take this thing, where's that stinky thing again? Right there. And I put it in the soil, it will release a lot of nitrogen. If I take that stinky thing and I mix it up with straw or with sawdust and I put it in the soil, it may not release because I changed the carbon to nitrogen ratio. So in a week, you get half of it out, and in 2 months, you get 70% of it out. And maybe if they kept going, they would get to 75 or to 78, but you never get to 100. So the shape of the curve is, it starts really high, it levels off, and it keeps leveling off. So the maximum that you can get out of it is maybe 70% or 75% in a time that is reasonable for your crop to pick it up this year. Right? We're talking about months, and maybe 70% of it, 75%, 80% of it gets released. The rest stays there. When does it get released? We don't know. Maybe another 5% next year, and maybe another 1% 2 years from now, and maybe another 0.5% 3 years from now, and only God knows, because it has to do with how recalcitrant or how liable that source of nitrogen is to release, right? So again, really fast at the beginning, and then it levels off. Questions?
Most of these nitrogens, amino acids.
They're proteins and amino acids, yeah.
Okay.
They're proteins and amino acids. You can send a sample, and as a matter of fact, I did for those two. You can send a sample and they will tell you how much is ammonium, how much is nitrogen, and how much was organic. They call it TKN, total Kjeldahl nitrogen. Kjeldahl was some chemistry nerds that Okay. So Kjeldal means organic. Anything that was organic from protein or from amino acid is Kjeldal. So this is another question about placement or about where you put it. And they used 442, that is the name, how people typically refer to pelletized chicken manure, and I see people nodding. And I know that it's very much used by avocado guy. Is that true, Nick? Yeah. So 442, and we'll see in a minute why. And the reason is that it's cheap by the pound of nitrogen. You buy a lot of nitrogen by buying for your dollars. You buy a lot of nitrogen for your dollars with 442. But again, 442 is pelletized chicken manure. They dropped it on the surface or they bury it. Of course, burying it is a lot of work, right? Because they have to till the soil. It's a lot easier from a particularly in a grove than to bury it. But look how much more nitrogen came out of it after 2 months. 70% of that nitrogen came out of it after 2 months, which is available for your plant to pick up if you bury it, compared to only 48% if it stayed on the surface.
Eventually, does it all come out, or does it get to 70%?
Eventually, it all comes out, but the problem is, the risk is, and I used to see it all the time in the Salinas Valley. You have this stuff that is high nitrogen and sitting right there on the soil, and maybe the storm comes, or maybe you're even irrigating, and you get water erosion, and now all that water picks up those pellets, and next thing you know, they're in the river. So eventually, will it release it? Yes, if it stays there, right? But the risk is that if it's winter and it starts raining, maybe it goes away before it breaks down. And the other thing is that, as I said earlier, mineralization is a function of two things. Who wants to tell me? Otherwise, I talk too much. You tell me and I take a break. I said we're in California and it's always warm, and then if you're growing plants, you're irrigating, and so those two will be
Water and
Temperature and water.
temperature and water, right? So if you drop it right next to your tree, if your sprinklers, or I don't know how you irrigate, maybe you irrigate with drip, so it doesn't get wet. And so it sits there. And it's common that you go back 2 months later and you're like, oh, are you still there? I put you there 2 months ago. What are you still doing there, right? And so now you spent money for fertilizer to give nitrogen to your plant, and now your plant is nitrogen starved, and you also spent money because all that nitrogen stayed there, right? And then maybe, I don't know, maybe it rains and it stays there and you'll get it 3 years from now. But I wanna make money today. I don't wanna make money 3 years from now, right? So you want that nitrogen to feed your plant so you get good yield this year. Does it make sense? Any questions? And guano, and you can see the other one, you can see the other column with guano, where you get the difference is even stronger with guano, right? If you drop it on the surface, only a third of it comes out, while if you bury, almost 90% of that nitrogen comes out. Does it make sense?
One is more expensive, huh?
I'll show you in a minute those numbers too. But yes. The last, yes, Mary.
So the question I have is on the surface application.
Yeah,
Is there a loss due to volatilization?
there can be, but the volatilization happens a lot particularly if the conditions are anaerobic. So you get a lot of volatilization loss. And I know that you know about these things way more than me. So maybe I should ask you that question. But it's what we call denitrification happens a lot if the soil is saturated with water.
I guess the question I'm trying to get at is that I think growers are concerned with the
amount that they're paying per unit of nitrogen and the
They should.
effectiveness of that nitrogen. And if it's buried in the soil, it's probably gonna become available at some point. But
Yeah.
if it's volatile, it's gone, it's never coming back.
Yeah,
And-
yeah,
And
definitely.
so with these organic forms, are they more prone to that than say a mineral fertilizer would be?
You know, they're more prone to that, but again, as far as I know, the conditions that favor denitrification are anaerobic conditions, because what happens is that I don't want to get technical here, but if you have oxygen, so our metabolism, you need some, we use carbon, we use carbohydrate that are reduced, and we use oxygen that is oxidized, and we do a reaction and we get energy out of it. If you're a microorganism and you don't have oxygen, then you say, well, I don't have oxygen, but I want a highly oxidized compound. There's this nitrogen here. There's this nitrate here. I'm gonna use nitrate the way that you and I use oxygen for my metabolic reaction. So if they had oxygen instead, they would use oxygen. And so that denitrification happens mostly in absence of oxygen, which is an anaerobic condition that typically in agriculture is caused by over-irrigation and oversaturated soil. But I want to show you this other graph here, which is a little subtle, and tells you the percentage of nitrogen in your fertilizer. So we are here with guano, we are here with the soy stuff that I brought, we are here with 442, that is pellet-style chicken manure. We're probably here with the compost, 2%, 1%. The y-axis tells you how much of that percentage you get out of it in about 2 months for your crop. So if you put 442, only 30 or 40% comes out of it. If you put that soy hydrolysate, 70% comes out. 70% of the 16%, and 30% or 40% of the 4%. Does it make sense? So if I have a lot, I give a larger fraction of what I have. If I have a little, if I go to the poker tournament and my wife let me took $1,400 to the poker tournament, then I'm willing to lose 70% of those $1,400. But if my wife only let me bring $2,000, then I'm stingier. I only accept to lose 20% of those $2,000 that I have at the poker tournament. Yes, question.
Tell me about using something about urea. Okay?
Yeah.
You consider that organic?
Got carbon in it.
It's an organic compound, but it's not, you cannot apply it in organic agriculture.
You cannot.
You cannot.
Okay.
Because it's synthetic. We make it with a big industry that fixes the carbon from the air, and then somehow they turn it into urea.
Okay.
So just to drive the point home, if you go AgroTribe, that is 2.5% or 3%, if only 30% is available for this crop, really we should call it a 0.8%, not a 2.5%. You're using guano that is 12% nitrogen and 70% of it is available. We should really call it an 8.4%, right? So, but also I want to tell you that the rest of that nitrogen is not lost. It's still there, and someday you'll get it. It's just not available for the immediate needs of this crop this year. Yes, question.
To get the 70% on the guano, is that when you have to get it into the soil?
Yeah.
that's
That number will be lower if you
If
just
you
drop
leave
it
it
on the surface. Yes.
So is the mechanism understood why you don't get higher than 70%? Or is that still a mystery?
There are some compounds that they call it recalcitrant. There's a lot of scientists that spend a lot of time studying organic matter in the soil. And so they say, oh, there is all this fraction. There's an active fraction, there's a passive fraction, and there's a recalcitrant fraction. And so some compounds that contain nitrogen are very, they say, recalcitrant.
So the nature of the nitrogen isn't all uniform. There's different parts of it. So it
That's right.
absorbs certain parts faster,
That's right.
other parts not at all.
That's right, that's right. And then also the nature of those nitrogen compound changes also because there is a lot of microbial activity. Maybe there is some microbes that make some polyphenols or some, what do I know? Maybe there's some lignin that is not, that doesn't, yes.
You gave a range for the plant in terms of what it needs as far as nitrogen. Does that change over the season?
It does, yeah. It certainly does, and that's a little more difficult to generalize, right? So maybe and I showed the uptake curves. That was the point I was trying to make. But typically for vines and for trees, you will get a big uptake in spring when you get leaf out, or if you have evergreens, it's still when you get flowering starting. So typically there is an uptake in spring. And if you're talking about vegetables, there is uptake that is mostly related to biomass, to how much biomass is
So
growing.
if I were doing tissue cultures, it would depend upon, my target would change during the season.
Somewhat,
Okay.
somewhat. Okay, so I'm running out of time. I love the questions, so I can't resist answering them, but I'm running out of time. You've got to think about your nitrogen balance. You've got inputs that are mineralization is one of them. We said you can get anywhere between 50 to 100 pounds of nitrogen out of it. There's fertilizer, you will know how much you apply. There's the previous crop residues that we talked about a little bit with somebody that includes the leaves that your avocados are dropping, or a cover crop if you apply. And again, probably you're getting close to 100 pounds of nitrogen. So you should, if you have these sources, you should account for them. So if you have more of these, obviously you have to apply less fertilizer. And then some of us use well water, and some of us unfortunately have nitrate in their well water. And if you're one of them, you need to account for that nitrate because it contributes to your nutrition. And I can show you how I can come out to your well and we can take one of these colorimetric strip tests to measure how much nitrate is in it, or maybe we can use a more sophisticated machine like this to measure how much nitrate is in your well. And then I can calculate for you how many pounds of nitrogen 1 acre inch of your irrigation water provides to your crop. The outputs, we have talked about them a lot. It's crop uptake and nitrification and leaching. If you want to get a snapshot of what the situation is in your soil right now, you can buy a thing like this, a probe, and you can take a soil sample, and if you take this little thing that kind of looks like a turd, and you will be walking around your field with these 2 buckets full of turds, and one is for the 12 inches and one for the 24 inches. And this is a procedure that has been conceived and developed for lettuce and then for other vegetables, and then has been used in berries. And as far as I know, nobody is using it in avocado. And I wish that somebody, Mary and I were talking about this. I wish that somebody developed it for avocado. And I wrote a CDFA grant with Ben Faber and Ali Montazar to do just this, and we didn't get the money. But I think that you can use it. And the big thing with avocados is that you want to decouple these 2 processes that you want to do. You want to leach your salts out, particularly your chloride. You want to leach your salts out, and then you want to apply nitrogen. But you don't want to leach your nitrogen. So you need to leach as much as you can to push those chloride out of your root zone where you don't have nitrogen. And then you want to apply nitrogen. When you apply nitrogen, you don't want to leach as much. And so how do you manage these two contrasting contrasting needs? Well, maybe you can sample, but there is not a procedure ready. And if you're interested on the quick tests, stay at the end. I'm gonna show you, I brought some soil, I brought the calcium chloride. You can go home with some calcium chloride, I have a scale there. I'm gonna weigh how much you need to make a gallon of solution of calcium chloride. And if you're interested, you can scan that code and it takes you to some website that tells you everything you always wanted to know, to learn how to do a quick test. You need, I'm past 8:30, so I'm gonna be real fast. You need to calculate how much you're paying for a pound of nitrogen. And if you're not already doing this, and I guess some of you are already, but if you're not, talk to me. If you look at this, you would think that this second row is cheaper because it only costs $3 per pound of fertilizer. But then it turns out that it costs $163 per pound of nitrogen, while this other one costs only 42. And this is also the reason why pelletized chicken manure, 442, and guano are very used, because it's probably the cheapest organic nitrogen that you can get out of it. So my prices may be a little not the same that you see, but I want you to learn how to do this. So if you don't know how to do this, talk to me and I'll walk you through the calculations. If you want to apply 5 pounds of nitrogen and your fertilizer got 3% on it, you need to divide 5 by 0.03 to calculate how many pounds of fertilizer you need to apply to your field in order to get 5 pounds of nitrogen out of it. And here I have another more examples that I don't have time for. This is a calculation with 442. It turns out you have to apply 2,500 pounds of 442 to get 100 pounds of nitrogen out of it. And I see that Nick is smiling, so I guess he can relate. And then there is also soil hydrolysate, which is what I have in that little cup passing around, that's got 15% of nitrogen in it. And some of us used to know it as BioLink, but then these days there is other products too, and I have a bag there that you can look at. If you inject liquid fertilizer, you need to make sure that you have time to flush it. That this time where your injector is off and you're only irrigating with fresh water is long enough to flush your system. And we can calculate together we can measure together with an EC meter. We sit at the last drip line or drip hose, and we measure when the fertilizer gets there, and we can measure how long it takes for the fertilizer to get there, and we will know how long it takes to flush. Or you can inject food color, and when you see that those drips start getting red, then you know that water got there. So there is simple ways for you to calculate how long it takes to flush your system with fresh water. You need to do it, because if that stinky fish emulsion sits in your drip lines, is a recipe for disaster, and it will clog your emitters. And make it easier for your irrigator to flush your emitters. Put a valve, don't put a nut at the end of your drip tape or drip line, so they can flush it. Your submains too, and your laterals too. And this is in grapevine. You see, you can put a valve, or you can tie it at the end. Do you think the one that is tied is gonna get flushed very often? So you want to make it easy for everybody to flush it, and this is what I get when I go there and flush it. All sort of junk comes out of it. And this is another example. Finally, and then I promise I will send you home, 442 has too much phosphorus in it. It has too much phosphorus in it. Because it has as much nitrogen as it has phosphorus. I remember at the beginning we said plants got 5% of nitrogen, only 1% of phosphorus. This is applying too much phosphorus, and that phosphorus sits in the soil. And then when the storm comes and all that sediment ends up in the river, we get eutrophication and all those things that we get in trouble for. So there's people that criticize organic agriculture saying, hey, well, it's not really very environmentally friendly because we're limited by nitrogen and we're forced to over-apply phosphorus that is environmentally hazardous. So I don't partake in the discussion, but my job is to tell you, be careful, and you can get a sample. It's really difficult for you to measure phosphorus directly, but you can send the sample to the lab, and they will tell you what we call Olsen phosphorus. That is mostly what we're using in California, the way they extract it before measuring it. And the values that you want to find in your soil are around this. You don't want to have more than 55 or 60%. I used to measure, again, in Watsonville and in the Salinas Valley, organic agriculture field where I get 100 or 150 Olsen phosphorus. And again, you don't want all that phosphorus in your soil because then it can end up in the river and give environmental problems. So measure it. And I guess you can use some of these high nitrogen compounds together with your 4,4,2 to decrease how much phosphorus you apply, although it will be a little bit more expensive in terms of fertilizer. And with this, thank you very much. Please complete the evaluations, have a burrito, have a glass of coffee. Thank you for coming, and I'll see you next time. And if you want to stay, I'll be around to play around with the nitrogen quick tests. Thank you. Sorry we're late.
Where's the evaluation?
Oh, you wanna scan that code? We're doing it high tech these days. Yeah, you scan the code. You scan the code and then it asks, it's only 2 questions, so it's easy. It's easy.
Good for you.
Thursday. But this month is canceled. So if you want me to be here on next Thursday, which I think is next week at 1 PM, just take one of my cards. Or I guess you can tell me now if you want to be there, I'll be there. Okay. I'll just call me or email me and I'll be there. But under normal circumstances, except for August, when they don't cancel the meeting, I'm always there at 1 PM. Thank you. My pleasure. Thank you for coming.
This is the first email that I've gotten on your class.
You know, because next time we're talking about nitrogen. And so the irrigated land use that, this is an opportunity for, to get hours, for people to get hours. This is actually Mary's idea. So I guess we need to thank Mary.
Well, I've been doing this for 4 years. This is the first email I've got.
I know.
Okay.
So I guess we need to thank Mary, because she decided, she told Sasha, email everybody, that email, it tells people an opportunity, very welcome, an opportunity to get hours of education.
Well, I don't have a problem getting hours of education, but
For the irrigated land.
absolutely.
Okay.
There's a lot of seminars online with.
That's right.
Through the irrigated land. So 2 hours a year is just not.
Right. Right.
Can I ask you? Yeah, I came here knowing that it was organic and I didn't have any need for organic knowledge.
Well, Joe, that's what I said at the beginning, we'll have other ones that maybe are more relevant. I can bring somebody on purpose to talk about race.
Okay.
I'm gonna do that.
Someone access your, all of your sites and everything at any time, is it possible?
Sasha, yeah,
Okay,
sure.
because I would love my husband to see some of these, and I didn't take pictures of them, yeah.
So we recorded this for him to watch.
I do that anyway, that's Tasha.
Sasha.
But she even helps me fill out my stupid
Tasha is
form there, you know, all right, thank you.
Thank you, man. Thank you for watching. You son of a. Thank you for. Thank you. Good to see you.
We can help. One of the questions, absolutely irrelevant. There's a lot. Well, it told me I couldn't be.
No, it really doesn't
Yeah.
work. Well, I got something in Russian.
I thought it, so it works for me. Huh.
You know, I get.
Yeah, so did I, and I had to do it a couple of times. At first it didn't work and then it did. Hugely, is that even a word, hugely?
Yes, it is.
Hugely, it's a huge word.
This is the evaluation people from UC.
Recalcitrant is a word too, although I have heard it very infrequently. I heard it more today.
Yeah, the question, and I know you can, the Williams Act, how the hell do I find out anything about that?
Oh.
You remember that? My parents signed that for it, the Williamson, 30 or 40 years ago, and I'm looking at paperwork on it now, after they passed away 30 years later. So there were some recent changes, I believe, and
Hi.
Yeah, we had. Zoom things also. Okay.
Right. So I manage a small grove. Okay, so it's like 50 trees.
Okay, avocado.
Yeah, and it used to be more, but it's just, it's hard around here.
Yeah.
because basically.
So I've been mulching chips and leaf mold and all this, for like 10 years now. Okay, so I've got this accumulated buildup of organic matter in the soil. And I had it tested a while back through the RCD. Okay. The guy told me I had the highest organic ratio that he's ever seen. Like, that's a good thing. I have all this system building down there that's like releasing nitrogen stages and levels.
Yes. The answer is definitely yes.
But it's hard to gauge everything.
But the problem is, if you keep adding carbon, if every year you
You'll have to keep adding nitrogen, but you do that anyhow. I mean, I do fertilize with nitrogen.
Okay,
I don't just rely on the mulch and compost.
okay, so I mean, again, the ratio, and I didn't have time to show, because we talked a lot, which is definitely a good thing. But I didn't have time to show. Well, yeah, I can put it, okay. So I didn't have time to show these other curves. Carbon to nitrogen ratio. But I was rushing towards the end.
So how do I interpret that? What am I looking at?
So if you have a lot of carbon, so wood chips are here.
Yes,
Wood chips are here.
right.
Right? And maybe a fresh cover crop that you grow it and you
Fill it.
incorporate it is with down here.
Okay,
So this is, again, the percentage of how much of that nitrogen that is in there, is released. So even if you have a lot of nitrogen in there, but your carbon to N ratio is really high, because you keep adding all
Right.
those
right.
high carbon to nitrogen ratio material, then although you may have nitrogen is there, it's not mineralized, and this curve goes negative.
It's called Williams.
Now it's not showing it. We call that nitrogen fixation, and in substrate, we call it nitrogen draft. So this, if you go higher than 40, this goes negative. It means instead of mineralizing it, it fixes it,
Okay,
right? So
but if you're adding nitrogen at the same time you're adding, mulch or chips.
it means that it pushes the average carbon to nitrogen
Okay.
ratio down,
Back in the way you want it to
like
be.
the way you want it.
So with the leaf analysis would show us those ratios, wouldn't it?
Yeah. Well, the leaf analysis will tell you if the plant has nitrogen, is it deficient or not.
Right.
But you can measure, you can take a solid sample and measure how much carbon is there, how much nitrogen is there, in the calculated ratio.
And you do that through this test kit?
Thank you. I loved it. Thanks.
Good, I'm glad it helped.
We don't have organic, but I love seeing you in your presentation.
You're too kind, good to see you. So, the tasks that we can do if you want together, and you can even go home with some calcium, I see that maybe somebody wants to do it, with some calcium chloride, will tell you how much nitrate is there right now. So that's a function of how much was mineralized, right? So if you see a lot of nitrate, it means that a lot of mineralization happened.
That's good then.
That's good then. But, so it's an indirect measurement of that mineralization happening.
Okay.
But you could also make some calculation in theory, which is what I wanted to show you here. Maybe you have 2 or 3 or 4% of organic matter.
Great. Okay.
So you can say.
Have you been doing it very long?
First foot of the soil,
5 years.
in 1 acre
Okay.
weighs 4 million
No.
pounds. Times 1% organic matter.
The break
Your
even.
case number would be 3 or 4 or 5, whatever the RCD told you.
Price of
And then 7% nitrogen in organic matter, so if you multiply this with 3, and again, for you this would be different, you get how many pounds of organic nitrogen is 1 acre.
That's available for the plants.
It's not all available, not all available, it's there, it's there.
So maybe 70% is all. That's, that number's been bandied about a lot.
The best case scenario.
Risk is
But
there.
check this out. Laboratory study that shown that at best, about 2% of soil organic nitrogen is mineralized in a 2-month period.
Where are you at?
So for those 2 months when your trees are hungry for nitrogen, maybe you
Like right
get
now.
2% of all these out. And so you say 2,800 or whatever the number is for you, it can be way higher, times 2%. Maybe you get 100 pounds. Maybe you get 100.
So I'll do that, because I had a soil test done about a year ago, year and a half ago, that I can read and I can see that.
Yeah.
I know where my fertilizer comes from a factory. So.
Organic and
What are the
way up.
rates?
Show these guys how to do the test, and you can join us if you want.
And what is the stuff you're getting?
Soil nitrate quick test.
Nitrate, so that nitrate is mineralized, it's actually available for the trees.
It's not, it's really.
Well, that would be interesting to do after all those years.
I appreciate that we're doing it. I want to keep doing it more and more and more. And, but it's not, and I only had 3 days.
So. Oh, you're doing the demo test. Who wants to see the quick test? We got the quick test here. So we got this calcium chloride. You can go to the grocery store and buy a gallon of distilled water. And then 1 gallon of distilled water takes 5 grams of this stuff. You can buy this stuff, it's calcium chloride, it's the same stuff you use to make pickles. You can go and buy this for $10, but you don't have to, because I brought the scale, so you can get 5 grams of it right now. Put them in this little bottle, take it home, and then you go to the grocery store, you pour it into the 1 gallon of distilled water, and now you have 1 gallon of calcium chloride solution that will last you until your grandkids will leave some of that solution for their grandkids. Because you use only 30 milliliters of this water every time you make a test. And you can go home with one of these to measure 30 milliliters. And this is what I'm gonna do now. I'm gonna pour 30 milliliters. Now I'm going it quick and dirty, okay? You're gonna be more careful when you do it yourself.
You're doing pretty good.
And just, so you put 30 milliliters of this, and then you add, let's say that you walked around with your soil probe and you sampled your soil. You put soil until you get to 40. And the whole procedure is in that article that I gave you. This is what you do, and then you shake it. And the calcium chloride, what it does, they call it flocculates, meaning that it makes it easier for it to settle out of solution. So you will shake it for 1 minute. I'm gonna just cut the little corner here because it's late.
That's just a flocculant. It doesn't chemically change anything. So if you're patient, you really don't even need to count. Just let it settle.
Very right. Very good.
Save
Very good.
5 grams.
Yeah, but exactly. But
Put it through a coffee filter. Yeah, or just go do some. Sure. Coffee. I have pickling stuff. I'm a certified
or, pickle maker, or,
I think there is something to do with the, sometimes some nitrate, it's very little, there is some what they call anion exchange capacity, mostly in organic matter, in the soil is very little. I think that the chloride also goes there and takes the nitrate out.
ion transfer increases.
But it's minimal, if I understand correctly, it's minimal.
Okay.
So your way is almost already developing there. And if I find something.
Keep the top on the calcium chloride because it's extremely hygroscopic, so we got more.
But then
Yeah.
you will take one of these nitrate tests that are meant for pools and for aquarium, so they're available and they're relatively cheap. These are the cheapest. These are better, they're made in Germany. One of these will cost you $100, but there's 100 of them. So each test costs you $1. And then you see that it's already starting to settle. The problem is that is a colorimetric test. So if I put it now, it's gonna look pink a little bit because of the nitrate, but also a little brown because of the water was dirty. So that's why we weigh. But then there is some coefficient that you have to multiply with, but then the final number that you get is concentration of nitrate in the soil that you can use to calculate pounds per acre, right? What you carry is pounds per acre. You know, by big test, you will know I've got 50 pounds of nitrate per acre. I don't know how much ammonium is there. There may be a ton of ammonium, there may be a ton of urea, there may be a ton of organic matter that's got a lot of nitrogen in it. So it's kind of a snapshot of what is immediately available to the plants, but also immediately available to leach, right? So, exactly. So that's why Mary and I were talking about that somebody should develop this for avocados because they are very, the leaching and the over irrigating that you do to push down those salts, particularly chlorides, you want to decouple them from nitrate. So maybe we could have a procedure where you can measure nitrate and also chloride, because chloride can be measured with these two, right? And you say, okay, I got my chloride is not too bad. They're not too high. They haven't built up in my soil yet.
We wouldn't need to leach yet.
I wouldn't have to leach yet, and I had a lot of nitrate. I'm gonna wait until my plant picks it up, right? And in a month, I'm gonna do it again. And now there is less nitrate, but my chloride are up. So now I will leach, right? So trying to decouple the two. So who wants to do it?
You're the
Just
expert.
dip it there, you just dip it there, and then you shake it, and then you look at it, and you have this colorimetric. Who wants to do it? You know,
Is our sample from 12 inches?
24, or just do both?
this one. So you don't wanna go all deep all the way. You just
Okay.
wanna pull it out. So you just wanna, see you got some soil.
Yeah.
So you want, wait, but I know you did the wrong side. You did the wrong side.
Well,
So you see.
both
This is-
sides.
this is-
Oh, it's just those dots.
Yeah,
Okay.
that's right.
Did not see
So
it.
let me show you. You're gonna put it
I
only.
I see them now.
No, I'll let you do it another time. So you wanna put
Okay.
only this and just you dip it and you pull it out.
Okay.
And then you shake it and you do it. But you don't wanna push it all the way down, just on the
I
surface.
think it says don't shake it, but
Just not shake it. So only on this layer of clear water that.
do not shake. It says
All
in
right.
bold type.
All right, so don't shake
We
it.
both win.
But you wanna try and avoid that it goes in the mud or else it.
Okay, I didn't see the
color.
little dots on there.
So you do this, you check this out, and this soil happens to have a lot of nitric of it. I secretly spiked it with fertilizer.
So this one
I can
is
put this on my garden.
nitrite and this is nitrate.
So the one at the bottom is nitrite and you wanna look at the one at the top. You see what I said at the beginning? You don't typically measure higher concentration.
I want it like this, right?
That's right, yeah.
Okay, so it's very high, 50 on the nitrate and 0.3 on the
Nitrite. So now you learn that for once I told you the truth. when I said that.
First time?
Nine tries, it's typically really long. If you guys wanna do it too, it's here.
It's okay,
Or you can take, you wanna do the whole procedure, it's here for you, if one of you
I
wants to
can
go.
take one of these.
I'd like to take one of those and some of this.
Do it, do it.
At home.
Do it, do it,
I think I can do that.
do it, do it, do
I
it.
gotta measure 5 grand.
5.6.
Okay. And you say, all the instructions that you're talking about, are they on the online, or did you have?
Yeah, did you scan
that
that code? Did you scan that
Yes,
code?
I did, but so it'll be there.
It
So
will be there, and if you can't find it, where you wanna put probably a piece of some now.
if nobody wants this, I'm gonna toss it.
Yeah, you can have it. You wanna put probably a napkin or.
I got a piece of paper here.
Yeah, that's right, that's right. So 5.6, and I'm gonna put up the slide again for you guys to scan it. Where is it?
And you said that'll test chlorides also?
No, you can buy
Oh,
another, you can buy another colorimetric strip test
Mhm.
that says chlorides instead of nitrate, but nobody has developed it, right? So that's why I would like to, I would,
Wait, it should give me some indication of when I need to heavily water.
yeah, but what's the indication? I don't know, right? I mean, you could buy one of these that says chloride, you can stick it in there, you get
Mm-hmm.
200. What does that mean? You get 50. What does that mean?
So you use well
water?
No,
Well, you got a lot of high chlorides, just
Well,
the water comes from
yeah,
like.
so how many hours how many hours should I run my sprinklers
I have
and
no
how
idea.
often? So it might give me a better indication, because right now,
Wait, I got you one.
I'm completely in the dark.
Yeah, I don't know. I'm with you in the dark.
I haven't had mine lab test, I only had 2.5 acres, so I've done lab tests. in the past.
I got 1.5.
Oh, really? Okay.
Water and then mix it with soil and there we go.
Well,
1 gallon of, 1 gallon of distilled water will make a gallon of calcium chloride solution like this one.
Okay.
Then you can reuse the bottle, and it's 30 milliliters of water and 10 of soil.
Okay.
And again, if you scan that code, it will kick you to the website where everything is very well explained.
Okay.
Or I can email you the code, or I can email you the link.
I took a picture of that.
Well, but it's gonna be difficult from the picture. Let me look it up for you.
okay, thank you very much. I did learn
Good.
stuff
Did you
and,
do the evaluation? You
yeah,
wanna
I
tell
did.
my
I
bosses
did.
that you learned something?
yeah, oh, no, I, the thing.
I thought you were the boss.
Oh.
And it's, and I definitely need to get myself one of these rock finders, because I have so much trouble finding rocks now.
Yeah, come to my place, you'll find plenty.
I'm in Fallbrook up on the top of the Sleeping Indian. It's all rock.
Yeah.
Oh, is it? Yeah.
So you were gonna give me I was gonna give you a suggestion for a topic,
Okay, yes.
details about cover cropping.
That's what I was gonna mention. cover crops.
Details. I
You know-
mean, not this
Yeah,
20,000 foot view of planting cover crops.
you know, the
Because there's a
problem
lot of
is,
details in it.
you know, the problem, I'll tell you what the problem is. If we were right now in Salinas
Yeah.
and you were growing broccoli,
Yeah.
I can think of 5 guys that have done research on cover cropping and high biomass cover cropping, low biomass cover cropping, how you kill it, what, can you use mustard? Do you weed whack it? Do you spray? How much nitrogen it
Do you
gives?
cut it? You know, when you need to get out in the field and it's
Nick
knee
Irvin,
high?
Right? At Riverside,
Oh,
Nick Irvin,
yeah.
she's been doing cover
Yeah, I
crop
didn't
work.
think-
The problem is
Right.
our environment. If you can put sprinklers on your cover crop, then you get, Mother Nature is gonna be the manager of your cover crop.
That's this year. Why? Because we had rain this year.
Yeah,
I'll be back in a
exactly.
second.
So that's what happens. Mother Nature is gonna dictate how effective your cover crop is.
Yeah, well, I tried a couple of times just to broadcast no way it works. You have to cover it, you have to
You
cover
gotta
it with.
scratch it in.
And you gotta irrigate it.
Yeah,
Well, I was able to get a really, really good cover crop this year.
What time did you plant or broadcast?
I didn't broadcast, well, I put seeds on, then I covered it with maybe a quarter of an inch to half an inch of compost,
What is the, plant?
vetch.
That's vetch, okay? Which is that nitrogen fixing?
It is,
Mhm.
it's a legume.
Okay,
it's also pretty invasive.
It is I spent a lot of time right here where is growing up to the cordon, just pulling it back.
Yeah,
I mean, it was a labor intensive as hell.
yeah.
and do you mow it or do you till it or what do you do?
Well, right
when it
now
dies
it's laying on the
back?
ground, it's mulch. I mean, it died.
So you
it's-
didn't even mow it, you just let it do its thing?
Well, part of it I did mow and part of it I didn't. But basically, all of it ended up being dead on the ground. That's effectively a mulch right now. And that's great for the summer. Okay, but I'm gonna have to till it in, but what I'll be tilling in is carbon. There won't be any nitrogen in it anymore, cause it's been lying out in the sun,
Hmm.
baking, right?
Yeah, but the nodules under the soil, because it is nitrogen fixing, so the roots, the breakdown of the roots is gonna help.
Yep.
And then the carbon source of the top growth is gonna eventually. Plus, it's also moderating some of the temperatures on the
Yes,
surface.
that's,
Everything was good.
that's a heck of a lot cheaper than mulching my entire vineyard.
Oh, without a doubt, without a doubt, yeah.
Yeah, if I just get rain like this every year.
So, was this a seed mix? I can't remember.
Yeah, it was. I had vetch, I had
Get the seed.
Grangettos.
Oh, okay.
We went to high school together.
Yeah, because
And
we typically have a combination seed.
Yeah, so you got my cards?
That we get
Call
from
me or email me.
Okay.
You have any questions?
Lockwood, and it is called,
I ended the New Zealand hours and also.
so it has
like,
vetch,
graduated
it has
college, being
pea,
like,
it has
oh,
fava, it
row
has,
crops. Row crops, citrus.
it has a couple of different
avocados,
grafts.
Chickens.
The idea is you have all the,
Yeah.
depending on what
And so I
happens in the
texted
course of
her,
the
okay,
year,
I'm
you'll
gonna
get the
bring my cousin
benefits
too, who
of
also grows row
one,
crops. So I'm like,
some,
cool,
or
and
all.
so I've been.
I would tell you, you will find no,
Oh, okay.
the three things I put in is vetch, oats, and clover.
Yeah.
You might find a little sprig of clover in here
Yeah.
somewhere,
Yeah.
okay?
At the end, I had no.
Yeah.
Completely fair. And I didn't see hardly any, of the oats.
I'm gonna.
Right.
Or yeah, clover. But, this was quite,
Holy shit.
holy shit.
Yeah.
But I'm not gonna plant it again next year, that's